All right. Particle moves along the x-axis with a velocity at time t greater than or equal to 0, given by v of t equals -1 plus e to the 1 minus t. Find the acceleration of the particle at time t equals 0. Acceleration is derivative of velocity. So v prime of t is a of t, which is e to the 1 minus t times the chain rule of -1. So let's call that negative e to the 1 minus t. So to find a of 3, just put the 3 in there. Negative e to the 1 minus 3, negative e to the -2. Be a very fine answer. Is the speed of the particle increasing at time t equals 3? Give a reason for your answer. So again, we've got a velocity function and we've got a question asking about speed. So we've got to be sure we can correlate those two. So let's find our velocity at 3 and talk about that. V of t is, v of 3 is -1 plus e to the 1 minus 3, which would be -1 plus e to the -2, which is -1 plus 1 over e squared. So we've got to be able to look at this and say -1 plus a smaller number is going to be less than 0, meaning our velocity is negative. So our velocity is negative. That really doesn't mean our speed is increasing or decreasing. It's just something that we need to be aware of. We still have a speed with a negative velocity, and our speed is always a positive number. So talking about is it increasing or decreasing, we should be talking about acceleration. And our acceleration from part 1 was negative e to the -2. Our acceleration at 3. So our velocity is negative. Our acceleration is also negative. Because the signs match, meaning we are decreasing decreasingly. Do you see how this graph is decreasing and concave down? But if I took its absolute value and reflected it over the x-axis, its speed would actually be increasing because of that. So the speed is increasing at time t equals 3. The reason for my answer is the velocity is negative, the acceleration is negative, therefore the speed is actually increasing. We're getting bigger in the negative direction. My velocity is going to be positive velocity. And then if I put in a number like 2, -1 plus e to the 1 minus 2, -1 plus 1 over e, recognizing that this is a smaller number than this, so it is going to be negative. So v is greater than 0 here, v is less than 0 here, therefore it changes direction at a time of t equals 1. I like how question D kind of almost comes right from C. Find the total distance traveled. We know he had a positive velocity, from 0 to 1, and we know he had a negative velocity from 1 to 3 because he changed direction in C. So if we set up two integrals and subtract the negative distance, we should get our total distance traveled. So the integral of -1 plus e to the 1 minus t should be -1x plus e to the 1 minus t times that -1. That would cancel out the chain rule. So we want to go -x minus e to the 1 minus t from 0 to 1. Put in the 1, -1 minus e to the 0 should give me that. -0 minus e to the 1 should give me that. So I'm going to have -2 plus e for my positive velocity part, and then my negative velocity part, -x minus e to the 1 minus t from 1 to 3. And remember, we're going to subtract whatever this is off. Put in the 3, -3 minus e to the 1 minus 3. Put in the 1, -1 minus e to the 0. So we have -3 minus e to the -2 minus, this was our -2 again. We can actually get a +2 in there, aren't we? And then we put all that together right here. -3 minus e to the -2 plus 2. Throw this guy all the way through. Change all my signs inside of here. Combine like terms. Got -2 plus 3 minus 2, which should give me a -1. I've got plus e to the -2. That would be my total distance traveled. Obviously, just leave it just like that. No calculator. Good to go. Go calculate.